right, so today we're talking about decimal place value. So we did place value a couple weeks ago. We're expanding it into the decimal territory. So the decimal is our most important home base to find first. What did we learn a couple weeks ago was the final place before the whole numbers run out. It was the ones place, I agree. Next to the ones, just yell.
Tens.
Tens, next to the tens.
100.
There's the hundreds. And then I'm going to stop because as we progress that way, it just keeps coming ones, tens, hundreds, but we get into different families. What's the next family of 1, 10, hundreds?
Thousand.
Thousands place. Beyond the thousands is the,
10,000.
well, as families, there's a thousands group of three,
Millions.
millions group of three,
Billions.
billions, trillions,
Quadrillions.
quadrillions, and then it probably doesn't really matter. But we went on that sheet like quite a while to like vigintillion and stuff, if you remember that paper. Today we're going to take a step to the right of the decimal. So anybody remember from other years what place this is when we get after the decimal?
Tenths.
It is the tenths. So these all end with THS, but they're basically going to have the same name. Next to the tenths
Hundreds.
is the hundredths.
1,000.
Next to the hundredths is the
1,000.
thousandths. So I'm just going to write down here thousands because I don't really want to write these all out. There's the 1,000ths, then the
10,000.
then the
100,000.
100,000s. Then we get to a group called the
Millions.
millionths. And I might have run off the screen, but it's going to go 1, 10, and 100 millionths. Okay, here's a quick way to do the places. However many zeros there are in the word tells you what place you're in. So like the tenths has 1 0. That's the first location. The hundredths, there's 2 zeros in hundred. That's the second location. The third location has 3 zeros. That's thousandths. The sixth location would have 6 zeros, that's millionths. If you just count the zeros, that's a quick way to just tell you what place that you're in. So the first little bit of homework, they'll give you a number, and they'll just ask you questions like, who is the tens? I didn't that one, tens. Just yell, who's in the tens place? Fine. No,
3.
tens. 3 is in the tens. 5, who's 5? Tenths, gotta hit that THS on that one. So 6, what's 6 about?
Hundredths.
Hundredths. Where's the hundred? 2 is hundred, 6, hundredth. How about the 9? That's the last one.
That's the 100 millions.
100,000s. And I would go like this, 1, 2, 3, 4, 5th position. So if we made a fraction, it would need to have 5 zeros. 5 zeros is 100,000, so that is the 100,000th place. What would come right before it? 10,000th place. Before that, 1,000th place. I think the only one I didn't mention was the 1 at the very left. What would the 1 place over there be? That's the 1,000 place. Question about just identifying basic places. Okay. After we get the decimal again, if we're saying them or spelling them, they have to end with THS. Also notice, if we're spelling it, you spell out the word thousand, including the D still, and then put the THS. Sometimes people will say thousandths, and they don't really say the D, or you don't hear the D. There is a D there. It's thousand. No one says it like that. That's silly. But when you blend all those sounds and say thousands, the D kind of like soaks in there. Same thing with hundreds. 100 has a D. If we go to the hundredths, there is a D before that THS. When you say it, you don't maybe say the D, your ear doesn't hear the D, but there is a D. So when we spell these out different times, make sure you get the D in 100 and 1,000 before you tack on the THS on them. Question about places. So most of the homework is going to have to do with the thing called expanded notation. Expanded notation is just a way for you to practice your place values, basically. There's no real great function to this. There's no scientists and engineers putting things in expanded notation like to do problems in a better way. This just exists to basically practice our place values. So what expanded notation is going to look like are these parentheses kinds of things. If they give you a regular number and say write expanded notation, they want to see a bunch of parentheses. If they give you a bunch of parentheses, they'll ask you for what's called standard notation, and then you just write what seems to you like a normal number. So here's the rule. Every number needs its own set of parentheses other than zeros. Zeros don't matter. We're just going to ignore the zeros for the purposes of expanded notation. Reload. So 2 needs to run a set of parentheses, 3 needs a set of parentheses, 4 needs a set of parentheses, and 5 needs a set of parentheses. Any number other than 0, we need to have it running its own set of parentheses. Within each group, we're going to take these numbers times their places. So what place is the 2 in? Thousands. What place is the 3 in?
Hundreds.
Hundreds. What place is the 4?
Tens.
Tens. What place is the 5? Ones. And then we're going to put these pluses in as joiners to put those all back together if we wanted to. We're never going to do 5 times 1 and 4 times 10 and 3 times 100 and 2 times 1,000 and add them all up. But if we did, it would be 2,345. You could check it that way, I guess, if you really wanted to, but I don't know that we need a check really on this. 4,050. How many groups would I need to create?
4.
2. Why 2?
Zeros don't get parentheses.
Zeros don't get parentheses. So who's running the first group?
4.
4. Who's running the second?
5.
5. What's 4 going to do?
Times by 1,000.
Times 1,000 in the thousands place. What's 5 going to do?
Times 10.
Times 10 for the tens place. And what one little thing am I missing?
A plus sign.
A plus sign to join. Question about those first 2? Can you bump me a little bit to the right? Because I want to go to this problem before I bounce back. This one I get into decimals for the first time. If I get into decimals, your place values are going to have to get into fractions. So first choice is, how many parentheses groups do we need?
4. Oh no, 3.
3. Who's running the groups?
5.
5 runs a group.
8.
8 runs a group.
9.
9 runs a group. Is it somebody other than our friend in the front middle here who's been the voice of the class so far? Somebody else tell me what to do with the 5?
Times 100.
Times 100. Tough day for chalk today. Okay, so we're going to go 5 times 100 because that's in the hundreds place. How about the 8?
Times 100.
Times a fraction, 1/100th. As soon as we cross the decimal position, we're doing all fractions from now on. 9?
1,000.
Not 1,000.
1/10,000.
It's 10,000s. Okay, so remember that trick. If it has 1, 2, 3, 4th position, we need to make there be 4 zeros. This was in the second position, so we're going to go 2 zeros on it. Question about taking a standard number and putting it into expanded notation. Before I move on, I would do half point on this on a test. What was that short?
The plus.
The pluses. Make sure we get those pluses as separators. Question about those? Okay, let me clear just a little bit of space here. I didn't budget enough space for this one. Now let's work it the other way. So this, you don't need to do the multiplications and add. Okay, I guess you could. It wouldn't get you a wrong answer, but it would be annoying to do all these multiplications and then add all these numbers together. All you need to do is like reverse engineer this and put the right number in the right space. This is telling you to put 4 into the ones place, to put 3 in the tens place, and 6 in the hundreds place. This is an easier one because I didn't skip any of the places. So ones place gets a 4, tens place gets a 3, hundreds place gets a 6. If you need to do it, you could draw these little blanks. This is again called the who place, ones place, and we just said the ones place needs 4. This is the
10.
tens place. We said should get a
3.
3, and then this is the
1,000. Wait, no, 100.
hundreds wants to get a
Six.
6. So you could do that. If you're doing that, what I would ask you to do is when you're done, erase those blanks. Okay? Because that just looks weird to have a number with all this stuff like underlined in it. It's just sort of weird looking. But we just want to write 634. Question about reversing it? This one's harder because I skipped some stuff. So this time we want to get 6 into the
1,000.
thousands, 4 into the
Tens.
tens. Who did I skip?
Hundreds.
Hundreds and ones. So what's going to go in there?
Zero.
Zeros are going to go in the ones I skipped. So if 6 is in the thousands, 4 is in the tens, we need zeros in the other ones. What's that going to look like?
6,040.
It'll be 6040. Question about that one. Okay, for the first time going in reverse, I broke out fractions. Can we still see me to here?
Kinda.
Just like nudge. Now we're good?
Yeah.
Okay. So we want 6 in the 1,000, 4 in the 10, 3 in the tenths, 7 in the 10,000s. So somewhere in the middle of this number, we're going to have to drop in some zeros, true, but what else is going to have to drop in to separate the whole number places?
Decimal
A decimal point. The whole number places separated from the fractional places, there's going to be a decimal point somewhere in the middle of this number. Let's do this one first. I guess it doesn't really matter how you build the number, but if we're doing 3 in the tenths, let's do that build first. Where's the tenths place?
The first one and the after. the
First one after the decimal. So we're gonna go with 3 right there, after the decimal. So since there's 1 0 in tenths, it's the first position right after the decimal, so we need a decimal 3 immediately. Let's do the 7 next. Okay, where's the 7 gonna go?
The 10,000s.
Okay, so how are we gonna get there?
You go.
0, 0, 0, then that.
Disagree.
You do 2 zeros and then you put it in there.
Agree.
Oh,
Because since this has 4 zeros, we need to get to the 4th position. So 3 filled the first position, 0 would go in the second position, 0 would go in the third position, but now we've hit the 4th position, so what number needs to go there?
Seven.
The 7 goes there. What place is to the left of the decimal point?
1.
Ones. Do we need to use the ones place?
No.
No, so that's
0.
0. What's the neighbor of the ones place as we build that way?
10.
Tens. Do you want to fill that?
Yes.
4. Then who's to the left of that?
Hundreds, fill it with the
Hundreds.
0.
With a 0. And then
Thousands, fill it with the 6.
thousands fill it with a 6.
640s in a row.
Question about that one. Okay, and then let's nudge me a little to the left because I ran out of room and had to use the piece back to the left. So 5's in the 100, 6 in the 100th, 8 in the 1000th. Do we need a decimal point in this one?
Nope.
Yes.
Yes. Because when do we need a decimal point?
After the 500s.
Yeah, anytime the problem has what in it?
Fraction.
Fractions. If the problem has fraction places, we will need a decimal point. Are we going to fill this immediate to the right spot?
No.
No, because what spot is it to the right of the decimal?
1.
What place is this?
Ones. Oh, no, the 10s.
That's the tenth. There is no ones place, because if we tried to put 1 over 1, what's 1 over 1?
1.
1. So there can't be a ones place. That just can't be a thing. Here's another way we could think of this. Every time we move up a level, you're multiplying 10. So every time you move down a level,
You're multiplying 10.
no, we're multiplying 10, moving up each place. So to move down each place,
Dividing 10.
dividing by 10, or multiplying 1/10, however you want to think about that. So if we're dividing 10, dividing 10, dividing 10, we need to step from 1 to be 1/10. But multiply by 10 takes us up, divide by 10 takes us back. Anyway, there's not a tenths place listed, so we need a 0 immediately. Is the next space filled or unfilled?
It's filled.
It's
with a
filled
6.
with a 6. Since this has 2 zeros for hundredth place, the second position needs to be filled. The third position
Filled with
is filled with an 8. Since this has 3 zeros, we need to fill that one with an 8. To the left of the decimal, who's that?
0.
It's a 0 because what's the name of that place? Ones place, and I never mentioned the ones place. Next place would be 0 for the tens place, and finally, the hundreds place
5.
gets that 5. Sometimes people take this homework home and forget what we did, and they try to like multiply this stuff all out and add this stuff all up. No, you don't need to do that. All we're doing is using this to practice place values. The numbers tell you the place, drop that number into the right place, use a good bit of zeros to just get things to position the way they want to position. But we're not adding or multiplying anything. We're just trying to use this way of writing to do places. It's quicker to do this. We'll go to this one where I'm on camera. It's quicker to do this than to say with sentences, 2 is in the thousandths place, and 3 is in the hundredths place, and 4 is in the tens place, and 5 is in the ones place. If you wrote that out, you'd have a pretty good sized paragraph just trying to write out who's in what place. But when you do this, it's a lot shorter way to write that paragraph. That's why they have us doing this way is, they're not trying to make life hard, they're trying to make life easier. They don't really want us to sit here and be like 5 is in the hundreds place, 8 is in the hundredths place, 9 is in the 10,000ths place. It's a quicker way to practice on place values. Question about place values and expanded notation. We're on 2 pieces of 2 pages. 76, there's a group of letters that's going to go A to G. 276, the A to G, is going to be just place value questions, like how I came in on this one and said, like, who's the tens, who's the tenths, who's the hundred, who's the hundredths. They'll give you a number like that, they're going to ask you a bunch of place value questions. The main thing we're trying to hit up in the back is set M. Set M is all full of expanded notation. So they'll give you some regular numbers, they want to see those parentheses. They're going to give you some parentheses, they want to see the regular numbers, and that's where we are. So